Well, hi, and thanks so much for joining me here in my shop today. I'm in the final stages with this radio. There's still a number of steps to go, but they're all kind of final things. So one of them is I'm going to measure the beat plus and screen voltages on some of the tubes in here just to be sure they're in the right range. And then the next thing is to complete the alignment for the shortwave bands now that they're working. And then then a number of other little items have to be taken care of just to get this back in the cabinet looking good. And then there's a final check of the alignment, the oscillator alignment for shortwave, and I guess AM too, once the radio's back in its case with its new dial plate mounted, which I also have to do. So it's still a fair bit to do here on the radio. Let's start with checking the various high voltage voltages in the set here. So I'm not going to use a red clip lead, I'm going to use a black one here. Okay, so I'm going to connect the chassis, I'm sorry, the negative lead of my voltmeter to the chassis to make these measurements. Okay, and we're going to start with the output tube. Now the output tube, actually there's a chart, but let's take a peek at a chart here. Okay, so this is the chart in the manual, and we're going to start with the output tube. And what I want to make sure is the screen voltage is 190 or in the range, and the plate is a little less than what the screen is. A little surprising to me it's like this, but apparently this is a common way to do an output tube. So, and cathode, and a 12 volt drop on the cathode, that's also very important to measure. Let's start with that. So that'd be across the cathode resistor, would it not be? It would be across this resistor right here. No, not that one. There we are, 470 ohms. This is the cathode resistor, and this is the bypass capacitor for it. 20 microfarads. So this is one, I haven't really talked about this, but this set has 1, 2, looks like 3 capacitors in a can, and I paid really no attention to them because I haven't heard a single hum or any reason to be suspicious of them. These ones are helping to drive out the hum. I think the field coil is the main hum killer in the power supply here, really. But this capacitor, so what I'm trying to say is these capacitors could be weak. They're small to begin with, and the radio will appear to be hum-free. There's maybe a humbucking coil up here. Doesn't look like it. Sometimes there's an anti-hum coil or arrangement in here which might also be quelling any hum that might exist in the supply. But this capacitor here does a different thing. It's a large capacitor bypassing this resistor, trying to not let the audio signal go through this resistor, or else you then have a three-way voltage divider. You got this, the tube, and this coil. I don't want that. Really don't want. We want all the power developing in here. We don't want any developing in here, signal power. So that's what this is for. That's why it's so large. This could be weak, and this would start dissipating some of the power that's supposed to go to the speaker, and the end result is less volume. Now this radio's got lots of volume, but we're going to check this anyway. So I'm going to look at my tube manual and get the pin out straight here for this tube. Okay, so the 470 ohm resistor, which I've never actually measured, is this one here, and we're going to measure the voltage drop on there. That's my objective. It's pretty tight down in there. You can see I replaced the capacitors, of course. Let's see what it is. Let's see what it is here. Okay, so it's going to be on this meter. Pretty sure it's this side. So we're expecting something like, it's this side. Yeah. Something like 12. 15.7. Well, that sounds great. I'm looking for, something there. Let's just take a look and see, what does this recommend? It should be typical operation. Sometimes they actually give the resistance. Plate, no, it's plate resistance. Load resistance, that's not it either. Okay, not said there. Typical push-pull. Cathode resistor, minus 25 volts and push-pull. 400 ohms. And fixed bias up here, typical operations, minus 18, minus 21, depending upon the plate voltage. Low plate voltage, we'll say 250 plate voltage, that's close to what's in here. What's in here is supposed to be 190, 170. So something less than 18. Hey, that sounds perfect. That all sounds perfect. So the other two tubes that have screens are the first and second tube in the radio. And those screens are lower voltage, 65 I believe. So let's go hunting. So without looking at what is what, we'll just poke here. See what we find. Well, there's the, that would be the screen voltage right there. We should find another one. Right there. So that's the plate. The plate is running at 225 and the screen is running at 80. That's about correct. And then the IF was the IF amplifier was the other one. We'll just poke around again. This is all grounded here. There we go. What about here? No. How about here? So there's the 80 screen voltage. Let's see if we can find the higher. There's the higher plate voltage. So plate and screen voltages are normal in this radio, and the proper bias voltage is on the output tube, which is very important. But there's one more thing that's worth checking, and that's how the other tubes are biased, just in case there's another cathode bias, another cathode resistor. So the cathode is here. No. The cathode, very hard to see on this one. Cathode. Yep. Look at that, 330. So the IF amplifier is biased this way. This guy is different. This is a very different arrangement. So let's check that. So we've got to find this 330 off of K. So that's number 1, number 2, number 3. I never noticed those numbers before. Number 4. So K 330 off the 6SK7. So we'll look for the 6SK7. It's in between the cans. That's it there. This time I'm going to use my manual to look at the 6SK SK7. Grid number 1 voltage, -1, -3. Those are the kinds of biases, but isn't this thing driven by the AVC? Remote cutoff pentode. I'm sure it's driven by AVC, but I guess it has a kind of like a landing bias or a base bias or something. Grid number 1, positive bias value. What is that? Grid number 1, control grid voltage, positive bias value 0 max. Why are they even putting that in there for? Grid number 1 to cathode. Grid number 1 to cathode. Oh, these are the, okay, so that's the interelectrode capacitance. I'm not interested in that. Well, this isn't helping much. Let's just go find it and measure it. So off the cathode is 5, pin number 5. Pin number 5. Okay, we're expecting a fairly small voltage there. Pin number 5. Excuse me. Still got remnants of my cold. So I think that's 1, 2, 3, 4. This is 5. So we see the bias. Oh my God, that's a positive value. Oh, wait a minute. I get a positive value there. This is the radio operating with no antenna. I was playing this yesterday for a friend of mine who was visiting. I just turned it on and started zooming around. It was picking up a fair bit of short wave. I was really quite impressed. It sounded great too. So what to do about this now? Because I'm expecting a negative voltage there. Why did this thing talk about a positive voltage in the manual? That's kind of weird. 6SK7. Because of remote cutoff characteristics, these types are able to handle large signal voltages without cross-modulation or modulation distortion, often used in receivers with AVC. So that's what's going on here, of course. So plate voltage max 300, grid screen voltage C curve, grid number 2. Supply voltage, I don't understand that. There's a lot of stuff I don't understand here. Grid number 1, control grid voltage. Positive bias value, 0. Why did they even say it like that? Grid, plate dissipation, grid number 2, input. Grid number 2, input. What am I looking at here? Am I looking at the wrong thing? I can't be. Characteristics. So, grid number 1 voltage, -1 or -3. We got +1, +2 rather. Let me measure it to the cathode. Maybe because I'm measuring it to the chassis, I'm getting a baloney. I'm measuring baloney. So now I'm using a separate independent meter here. It's not plugged in or connected to ground or anything, so I can go right into the circuit here if I want. Any which way at all. So I'm pretty sure this is the bias resistor here, and I think the ground is here, so we're going to go here, and that's connected right to the chassis. I can see it, so I'm going to get the same reading here. I'd be stunned if I get something different. 2 volts, 2 volts positive. Wow. Okay, so this is a really interesting situation for me. A couple things roll through my head right away. One is the tube is bad and there's a grid current of significance in this tube. That's one possibility. How else does this get positive? The only way it gets positive is because the tube is driving it there. I think. Or am I nuts? You know what? Maybe I'm nuts. Because I'm reading a cathode resistor. I'm reading it in... Yeah, you know what? This is fine. I'm reading this kind of backwards in a way. Because what the cathode resistor really does is it drives up the voltage of the cathode so the grid is left behind negative. So you expect to find the cathode being driven positive. But you expect to find the grid negative to the cathode. Isn't that what I just tested? So, grid as compared to cathode. There we are. So I got my meter to say negative. Yes, I just reversed the leads. That's basically what I did. I think this is the correct way to do it. Yeah. No problem. It's just me. Just me. Okay, that's good. So everything checks out just fine. So you can also see the clip lead I have in here. I have the red lead, or the sort of the, oh my gosh, is that a short? No, it's fine. Red lead here. I have the black lead connected to the chassis up here. It's just a handy point, and this is going to the scope. So I'm showing you how I'm doing this next test. I'm going to try to get the characteristic curve onto my scope for the guess it would be for the entire radio. Okay, I think we're ready to ask the question, is this radio properly aligned through the IF? And so the way I'm doing this is I'm sending in a signal, a sweeping signal that's sweeping through the IF frequency of 455, starting roughly 15 kilohertz below and ending 15 kilohertz above. The device that's doing this, the sweep generator's also got a special signal coming out of it that's on this cable, which comes over to the oscilloscope here and moves the dot across in accordance with the frequency it's putting out. So here it's putting out the lowest frequency for, what did I say, around 440, and here it's putting out the highest frequency, the top of its sweep range, 475 I think. And in between, what you see is the result of the output of the IF. You're actually looking at the AVC voltage in the radio. So that's the shape of the response, more or less. Now we'll fill around with some of the screws in the top here, because even if I muck up the radio I can restore it no problem at all. Now we've got another meter showing us something here. So this one is showing the AVC voltage. It's connected, here's its cable right here, right to the same terminal that the scope is picking this signal up from. So this is reading the AVC voltage, or maybe I should say the RMS equivalent to that. That's really not the right way to put it, but it's something like that. So you'll see as I tune, well, I won't tune the radio. If I tune the signal generator, we can see this go up and down. Well, I can't tune the signal generator, it's sweeping, Jim. Well, I can change the output of the signal generator strength, and we'll see the AVC voltage go up and down. It's 0.6 volts right now. I just turn this control, you'll see it go up and down. You see the same thing on the scope happening. Same deal. So this is now telling us we have an AVC voltage of 0.9 volts. This is what it sounds like. So that's the sweep going by the tune point of the radio, the tune point of the IF. When the sweep reaches 455 or so, starts generating this, it makes a sound in the speaker, a popping sound. It's in conjunction with how fast the sweep is going. Really slow down the sweep, we'll hear pop, pop, pop. So now here's the deal. My sweep generator is set to sweep 10 times a second right now. But that looks like maybe twice a second at the most. So when you're doing this kind of test through a radio like this, the radio is responding to the signal by altering the AVC voltage, which you can see popping up and down on here. I want the sweep generator to sweep really, really fast, so the AVC voltage doesn't have time to go up and down and starts kind of leveling out, sort of the average voltage. And what I'm saying doesn't make 100% sense, so I'm going to shut up here. We'll just put it back on the fast speed. The deal is, this is slow. And why? I don't know. All the controls are set properly on it. So something I believe has gone wrong in it. So that's fast enough to get this on there, but I'm afraid it's not fast enough. I believe this rise here is from the slow sweep. But anyway, let's see if we can figure out if this is 455 or not. A couple ways to do that. One is I can introduce a 455 signal, and we can look at it and see where it is on here. It's a little tricky, but we can find it and prove what this point is. And you know what? That's the most certain way of doing it. And since we're all about certainty, what I'm really about is just getting myself so confused and balled up, I don't know which end's up. Let's see if we can get there. I can probably get there. I usually get there. So we're going to stick another signal into the radio. See if I can find a way to do it. There we are. I'll take the output from here, and we're just going to hook it right up to the antenna. both signal generators will be firing at each other. I don't think that's a big problem. Let's see. Okay, a little reduction when I hook it up, of course. Each signal generator is going to be shooting its signal into the other. But again, I just don't think it's a problem. This signal generator is set low. Now we want to set this one to exactly 455. Well, just close right now. Oh. Wait a minute. Let's see. What's the action here? Here we are. So you hear it go by? Excellent. Now, the trick is to look at that display on the oscilloscope very carefully. And what you're going to see is some little wiggly thing. In fact, I think it's right here, right now. A little wiggly thing. Maybe if I put the output up a little higher, the wiggly thing will get a little bigger. Well, it's all over the place now, isn't it? So I'm going to turn it back down. And you want to keep an eye on... You can't. You'll have to trust me. I'll just tell you what frequency we're firing in there. So just by listening to the radio now, I'm going to tune the what we call the marker generator and move the marker frequency. And listen to it and watch. So again, it's very tricky to see in the camera. But this line, let me show you what this really looks like. I'm making a little diagram here. Because if you're going to try this, you need to know what to look for. It's not a pip. Some equipment will produce a nice pip on here that you can see. That's not what's happening here. This is like an interference pattern. Yeah, it is an interference pattern. Look, I think I can write on this. Here we go. So hopefully you can see this. So we have this signal going like this, right? And we've noticed it's almost like I've drawn it. It's a little drawn out on this side, a little steeper here, something like that. Maybe the other way around actually. A little higher up here. There's some funny things about it. So if you look closely at it, if you were able to, you would see that there's a wiggle that starts here, gets bigger, and then it kind of draws out like this, and then it returns like this. This point right in here is what I'm trying to spot. This spot. This represents the frequency that is actually coming out of the signal generator over here. Let's see if I can get this onto camera a little better. So now you look at the image and no, this is probably not going to work here. I'm just not going to be able to make this visible on the camera. You know what? I'm not gonna, yes, I will be. I will make this visible. Okay, there you go. Now you can see just to the right of the dip, there's that funny wiggly part. I'll move it around by changing the frequency of the signal generator. And you can hear the effect. So you see the wiggly part I'm after is on the downward slope. Now it's right at the bottom, right where I would want it to make a measurement. And then it's off the other side. So it's not a pip, it's an interference pattern. Here it comes back. I'm going to set it right at the bottom. Right there, I would say. Now, a couple other things we get to do here. One is we could turn the volume down, not listen to it. We get to look at this meter jumping around like that. Well, I'm going to retune the, well, by now you've spotted this. So 455 is actually 453 on here. So this would suggest that the IF is tuned to 453. 455, sorry. 455. But let's fool around here a little more. First of all, just let me look at the scope here. Okay. I'm going to watch the scope over here. I'm just going to move this a little bit just see. So that's clearly off to one side. It's still 453. And this is clearly off to the other side, 454. I say that's back in the middle there, 453. So I think that's good. That suggests to me that this is really quite good. Nicely done. Now, the shape of that curve is kind of funny. It's kind of a little bit wonky here. I just force the camera to do its thing. Oh, there's a lot more stuff over here than there is over here, so it doesn't look balanced. Is that from this signal generator? Let me turn the interference guy away completely. You can still see that there's something different about the curve here and the curve there, and I think it's what we're looking at is because of the ABC response. The ABC voltage doesn't track exactly the incoming signal. There's a capacitor in there that is integrating that into something a little smoother. Now, let me try something really interesting. I have another sweep generator here. That's right, I have another one. So a kind viewer in California heard me complain that this guy started breaking down, and he has another one of these exact same sweep machines, which he actually sent up to me. I have it here. I can't believe it. He mailed it to me. So I'm going to quickly set this up. I haven't tested it at all yet. We'll set it up, we'll give it its first test, and we'll find out if it's working well, and perhaps the sweep is faster, and we'll be able to compare it to the sweep coming out of this one at the apparently slow speed that it's going at. Also, now that I have two of these units, there's a really good chance I can fix this one with the help of the other. Okay, so let me get that up on the bench here. I gotta find a little bit of space for it and stuff. Let's check it out. Okay, so I've got the new machine sitting here. Of course, my old one is still up here. The old one is what's connected and causing that display. I'm going to transfer the leads or use other leads to connect this machine just as this one's connected, set it up the very same, and see if we get that out of it. This will prove that this machine's working, and we'll also discover if the sweep speed is faster. I'm going to put that in, so we're just going to match up the button settings here. Right now, these don't matter. This guy should be on run, like that. Well, the first step, well, let's turn it on. Make sure yeah, good, red light comes on. What we'll do is we'll hook the output, the sweep output. Now we'll hook the sync output to the frequency counter, just like this one is. This is kind of I don't want to say a cheating way, but it's a way to get a signal out of the signal generator strong enough to trigger the sweep generator and be independent of the actual test output down here, which has all kinds of padding and stuff you can fiddle with. Okay, so we have no signal showing up at all. Now, why would that be? So here we go. We're in trouble already. Make sure all of these are set down. This is not going to work for me. Doesn't mean there isn't. Oh, I saw a little flash there. So there's pads on here. There's no attenuation. As far as I know, this is going full tilt. That's not the right thing. Did I do the right thing here? Sync output. It's not going to happen. Oh, okay, well, we're just going to ignore that problem for a moment here. Actually, let me test it back here. Is there something funny with this wire? Maybe there's something funny with the wire. No, so that's the sync signal from this. So that'll kill it. That'll change it. Shouldn't affect it. Just looking to see what affects this. Sweep started. Well, I have these out. That shouldn't matter. That should just give me a fixed number here, like that. Uh-oh. Let's try it again then. So if I can't get these, this is a total sidetrack from fixing the radio. If I can't get the signal generator here to tell me what frequency it's on through this frequency counter, I can't make much use of this at all, unfortunately. But I imagine it's just a minor deal here. Phooey on that. Now, there's no reason to think this isn't working. This could easily be working. So what we'll do is we'll switch over to the main output here. Let me pat it down. We should probably... Oh, come on, man. Let's show me... Wow. Okay, I haven't got it turned up. Turn it up. Stop it from sweeping. It's not sweeping. It is stopped from sweeping. Well, there's funny business with this machine. And that funny business is probably more me than anything. Let's look at the output on the scope. I'll do that one last thing, and then oh. No, I don't think so. Oh boy, that's loose. Okay, so the main output from here, we'll just throw it onto the scope. See what we got. Okay, I'll put this back on the regular thing. Move that over. Surely to goodness you can see that. Oh, maybe that's just hum. I think that's... What is happening here? Have I got the right thing hooked up? Am I confusing two machines? I am. I'm working away on the controls, and it's supposed to be this one. That's definitely it. Well, I think maybe I've got it set to an extremely low frequency here. Let's jack it up. Something a little faster. There it is. Okay, so okay. There's the output, no problem. There it is. Well, at this point we can look at what's coming out of the sink here. Let's do that. That's easy. What's coming out of the sink? So there it is. Sink pulses coming out. Let me give it just a little bit of a better view. Well, that's interesting now. I see a nice dotted line. I'm just trying to get the trigger to... Trigger... And won't. Well, anyway, you can kind of see that this is a... that's very hard to see on the scope. The upper line, the only one you should be paying attention to... Oh, wrong control. There. Sync pulses, I can see them quite clearly. Now that's what's coming out of the new one, and what's coming out of the old one. Okay, pull it out, stick it in the sync pulse. What happened? Okay, so it could be a very different frequency here. There it is. There they are. You can see them a little better here. So there's the sync pulse, and the divisions are roughly 2 divisions of voltage. Now, how can I vary that? Can I vary that somehow? No, that's not the right way to vary it. So I think this is probably a fixed output, a certain level output. You really can't change it. And it's intended to drive something that requires synchronization, and my frequency counter is fine. It's perfect for that. So I'm going to switch back to the other one now. Why is the other one any different? So 2 divisions. Switching back to the new one. Oh, well, here are 2 divisions. It's exactly the same. Why is one triggering my frequency counter and the other one not? How can this be? So they're both huge distraction here. Both are producing essentially the same kind of signal from the sync out. One of them will trigger my frequency counter, the other one won't. Why the heck is that? Let's go back and put this on because I'm just confusing everything all the time. Is that what it is? Oh my gosh, it's reading. So we changed the frequency here. Oh, okay, well I have no idea what just happened, but anyway it did. And now it's done. Okay, so think hard now. So we have the sweep output. I really don't know what was going on there. When I put the sweep output onto the channel 1 input here. And we want to put the main output into the radio. That's just by taking this main output and moving it to this one. Oh, turn this down, put some pads on. Okay, turn up the little radio. You should hear this. We're on the 10-second speed, so you would hear it once every 10 seconds. And you probably couldn't even hear it. So we're going to speed it up. Wait a minute, let's get the scope showing the right thing first. So we can go back to X. Oh, turned it right off. Go back to XY. Move. Oh, I monkeyed around with this to the point where goodness knows where it is. Okay, so it's not sweeping. So it's not sweeping on the scope. So we started sweeping. Let's check the frequencies here first. So, okay, that's right. We want this to be 440 or somewhere around there. That doesn't seem right. There we are. So this has 10 decade settings plus another setting, and on the other setting, this vernier takes over complete control of the frequency, all the way up to whatever you set here. Just in case you've got the same machine, you're wondering what I'm doing with it here. So I can set this to just about anything I want. 440 would be a good spot. 450, that'd be 15 below. Okay, so there's roughly 441. That's about as close as I'm going to get. Now we'll set the stop frequency. We want that to be 15 above, 470. We want it to be 470. Same thing here. Let me set it like that, and now I can go the whole range here. Whoops. I can't get the whole range. What happened there? Well, we can do it this way, just as easily. 470. Okay, so that should be sweeping such that 455 is right in the middle of the sweep. So we start the sweep by turning off the stop. There, can you see it moving there? It's moving really slowly. Oh, it just went by the radio. Did you hear that? I'm sure you heard it. Let's pick it up to once per second. Oh, there it goes again. How could it be going again? Oh yeah, that's right. It's just sweeping the IF, so it's pretty quick on it. Once per second. That sounds correct. So when I use my sweep generator, this takes about 10 seconds in this setting. So that means we're going to get full blast up here. And give us a better result on here. Just setting it here a little bit. Switch to this camera so you're looking right at the screen. interesting. There's a little blip right there. So I'm going to turn it up a little more amplitude, a little more signal strength to the radio. Now, listen and look. Swish pop, swish pop, swish pop. So the swish is the forward movement of the frequency across the tune point. The pop is the reverse movement at a much higher speed. So what the sweep is really doing is sweeping across slowly and then shooting back. And as it shoots back, the frequency drops through the IF again and makes that sound. And you can see it. Now look at the difference of the shape. So I get two completely different looking curves from a signal passing through the IF in this radio. It's just because of the speed and the effect of the AVC on it. Now, oh jeez, I looked up and thought, oh my god, it's going full blast. No, I'm looking at the wrong machine here. So let's speed it up faster. So now you don't really see the reverse one, because I believe the AVC voltage is holding in roughly the same place. So you don't get a different impression of the response curve. And notice it's right smack dead on. Wow, that's just luck. I'll turn up the input signal here. Oh, what am I doing? What am I doing? Oh, I'm turning the wrong control again on the wrong machine, for crying out loud. I gotta stop that. So there we are. And then you can see this kind of tipping downwards and this kind of rising up extra high. This, I believe, is AVC effect. Let's speed it up even faster. Yeah, that's what I wanted to hear all this time. So this, the sweep is going full tilt. You get a nice display. That's what I can't get with my other sweeper at its slower speed. So this reveals some strange things here. What's this bump all about? I don't know the answer to that question. The other signal generator is still connected. Let me bring it down. Let me bring it to 455. Pretty cool looking on the camera. So I would say that's the point where the sweep, where the that would be it right there. It's easier for me to see with my own eyes. So let's see if I can fill it with the camera and get this really nice on the screen here. Just bear with me a second. I'm going to change like the camera brightness setting. That's a little better. You can see how beautifully balanced this weird thing is. And what do we get for a frequency? Kenneth, what's the frequency? You can't read it. 453 flashing with a 4, so it's dead on. So, okay, again, IF checking out fine. Excellent. Found out my new signal generator is working properly. You can do the job. Double excellent. So we're exciting morning in Jim's shop here. What to do now? Now it's time to finish off the alignment of everything but the IF, and that's a pretty simple matter now. So I'm gonna set up for that. I'm too excited about all this stuff that's kind of just happened here. I'm gonna set up for general alignment. I'm gonna go watch TV for a few minutes actually. Kind of rest my brain here a bit. Yeah, watching TV doesn't rest your. Well, if you stay off the news, stay away from the news. Okay, how about that? There's 3 cameras going now. So one is the main camera looking at the radio here on the left side of your screen. Then obviously I got the scope camera up here looking at the scope. And then I have a last camera looking at the dial setting so we can see what where we're set on the dial. So the first thing I'm going to show is what is the effect of tuning a radio. Now we really shouldn't see any effect here. I think we're looking that dip on the scope is the IF response. We're sweeping just an IF signal through the IF. Right. And so if I tune the radio, we really shouldn't see a change, I think. But watch. Yeah, it's all the way one way. Not much of a change, okay? Not much. I mean, it's really nothing. But it's something. Anyway, it just goes to show you that, or goes to show me anyway, no matter where you go on the radio, everything is kind of connected to some degree. Okay, so there's a little kink in the shape of that curve. That's kind of got my attention there on the upward side or the right hand side. So just for fun, I'm going to, most of this is done for fun. I'm going to twiddle the screws in the IF here. I just watch the shape of that curve. Now I know it's at the right frequency, so I don't want to move it left or right, but the shape change, well, that was kind of interesting, isn't it? Look at that. Okay, well, let's fiddle with the shape a little bit. Now, I don't want it to change frequency. See, it's moving back and forth there? Don't really want that. Okay, let's try these ones. Can you make the kink go? Oh, that's pretty interesting there too. There, look at that. You can hear that. Wow, okay, so that is really cool. One more screw to fiddle with. Oh, come back. Well, let's see where it is now. Its maximum is right in here. I'll bring in right in there. I'll bring in the other sweep and we'll measure where we are. I don't think it's connected anymore. Son of a gun. Hang on. While I just connect the marker signal generator here. Okay, I'll bring it up actually downwards to 455. There it is. Put it in the sweet spot, I would say. Right there. And we look upon the frequency counter. So that's perfect. Okay, that's 455. In fact, that's excellent. So we got beautiful. We got a great shape. Turn down the sound here. We got a great shape. We got it right at the right frequency. I don't think we're going to get any better than that. Okay, so now we'll do the alignment deal. I'll move this camera here. Leave it here. Here. Getting a little tight in my shop here, pulling this off. So what we want to do is we want to check the dial setting by tuning the radio until we get the right number up here. And on my screen, I can't put this on your screen, I can put the instructions here. But they won't come up on your screen. So what we want to do is I want to feed a signal in at 1400 and it should be at 27 degrees. So what I'll do is I'll tune the radio to 27 degrees. It's almost there. 27 would be right about there. I'd say that's 27. There's zero parallax in the way I have the camera arranged. So yeah, that's 27. Turn it up a bit. Okay, so we want now to listen only to the signal. We don't want to hear the sweep. We're going to wrong controls. Boy, you know how many times I've reached up for this and wheeled these controls and nothing's happening because it's this machine. I've been in a panic a few times off camera. Okay, so we're going to kill this. We're going to stop it completely. I'll just switch it right off, so there's no chance Well, that makes for a boring display on the scope, doesn't it? Let's put it back on. Okay, now I'll tune the other signal generator until we hear the tone from it. And it should be at 1400, wasn't it? 1400. Here we go. Okay, down from 1600. 15, 1450. Right past. Something happened on the... There it is. Okay, so I'm not sure the funny shape here means much anymore. Maybe it does. But that's tuned in. It should be 1400. And in fact, it's, oh, not bright. 1588. So what I'm going to do, let's think for a minute. Is there anything going on here that I've accidentally shifted this radio off its rocker, so to speak? No, I don't think so. I think everything's fine. So, so I'll set this to 1400 and we'll jack it up. 1400. No, can't hear it at all. That's maybe because I have the other sweeper going. The sweeper's triggering the AVC. AVC's quieting the whole radio. So I will turn off the other unit. How about I turn it off the right unit here? One of these controls. There. Now I was expecting the radio to produce a little more hiss. I'll turn it up. That's better. I got half a screen. You got to be farther away, Jim. Okay. 1400. Wow, okay. That's a lot of signal there. Sensitive radio. Good. Once again, checking it. Oh, too low. 1388. I'll set this to just above there. We can still hear it a bit. Now it's one of these two holes here I've got to adjust. I think it's the one, it's the one on the left here. Okay, so what we want to do now is, and I don't know if you're going to be able to see this. Yeah, you can. Get this to say 1400 on this meter. Hello meter. This meter is maxed. Bring it up. Uh-oh, something wrong. Hold on. Total mistake being made here. Total boob up happening. It's not doing anything because I don't think I have this on. Jeez. Duh. That was close. So what was I hearing when I was tuning this in and had this thing on the short wave band? Goodness knows. Goodness knows. Let's try again. We're at 27 degrees here. Right? Yes. Nobody's home. How can that be? .26, I hear it. That's a little weird. That's really very strange that I can't. Oh, right. So I'm connected to the shortwave antenna, and if I remember right, the shortwave antenna is shorted when I'm in AM. So I just probably not feeding any signal in. So let me do this a different way. I'm gonna just try to transmit the signal through to the antenna. I like that a better way. I think that's a better way anyway. Change of plan. Change of plan. Change of plan. So this will just, I'm just hooking up the signal generator to this coil. Just put the coil near the radio. Turn up the radio. Now. Whoa, what was that? Okay, it's showing up now. Just, what's that? A couple other spots. Oh boy, that's bad. Uh-oh. So I'm saying uh-oh because we're getting a very strong response, way off. This is 1250. I think the radio's tuned to 1400. Let me double check. 1400, 27 degrees. That's certainly where it is. So it's picking up 1250 strong. It sounds like it's way off. Way off. Let's keep looking there. Anything else coming through? Now that could be an image. There's something at 1320. Bunch of stuff here and there. Ooh, it's not very good. And there's the 14. I think this radio's wrong. I'm going to leave it at 14 and I'm going to turn this. This is the local oscillator. I'll try to get that strong one in there. Well, that's pretty strong right there. I just barely moved it. Like I barely touched it. What do we got happening now? Now we've got the radio. Really coming up nice at 14. Any other spot? Now I've got a fairly strong signal blasting away at the radio here, so. But you can see it is sensitive to some other spots. Quite a few others. Oh, there's another strong one there. So that's it. So okay, so this one is coming in at 1502. And this one's coming in at 1406. 1502, 1406, that's just under 1,000. That's like 995. If you take 455 and double it, you get 905. Is that right? You get 910. Is that right? Is that right? 9, you get 910. I should have these numbers memorized, for crying out loud. So I'd expect to find a 910 cycle difference between the proper signal and the image. That's not quite what's happening here. The image is really strong, but the image is supposed to be knocked out by front-end tuning. So maybe that's the problem with this radio. It just never ever did get aligned very well. Okay, let's assume that's the problem. So this is the 1400. Get this meter here. Well, I don't want to tune 1406. What am I doing? 1400. Take it down to 1400. And that should be 27 degrees. And what do we see? Well, it looks like 28 degrees to me. 27 and a half. I would say, just for the sake of being as accurate as possible, even though there's no reason to do this accurately, because I still have the whole dial plate issue. This should really be about here. That would be 27. We'll do the local oscillator again. So get the screwdriver in. Come on, man. Just touched it. Just nick it. There. Okay, so that's about as good as we're going to get the local oscillator set for the AM band. So it's reading, it's picking up 1400 at 27 degrees on the dial. Now the other one to do with this is the antenna tuning, which is C1, which is this one up here. So this is about boosting the signal. I've got it tuned in properly. Let's see if we can boost it now. Where'd it go? You know, I touched that control and it just dropped right off. Touch the screw. So I can make the signal a little stronger here. I don't like moving this stuff. The reason it's disappearing, I think it's because the radio is retuning as I get this antenna close. Something's retuning a little bit. So in the instructions it says keep this coil 4 feet away. I'm 4 feet away here. Yeah, that's it. This guy's putting out everything he's got. Wow. That's kind of surprising. That doesn't seem right. My experience with radios and doing this is that this should be blasting a signal out of the speaker. Was it just, maybe I just have the volume turned way down? Could be that. I don't get it. Something's not right here. Something's definitely not right. Let's tune around. Look at that. It's down here. So this has got to be 1400 here. You can see on the scope, by the way, the vertical line is giving you the AVC, same as this meter. Let's so that's where 1400 is. I got to drive it way up here. That was a badder idea. wasn't a better, it was a batter. Okay, I want to knock this down to 27. Oh, it's way up at 40. Okay, where are we? 25, 26, about 27 there. Okay, does this appear anywhere else now? That's 27. Yep. Yeah, notice we don't hear any of those side guys anymore. Yeah, I don't think that's dead on. That's 27. No, it's way off. So it's still off. So we're at 1380. Let's put this back to 14. And let me try a plastic tool here. Just in case the metal is throwing it off. Okay. Maximum. Oh, what just happened? I think I bumped the tuning control. Yeah, we're not on 27 anymore. Whoa, where'd the signal go? So that's 27. There it is. Now the ABC is really affecting this, so it's tricky. There we are. You can see my ghostly image on the scope there. Hello, everybody. Let's turn that down. That must be blowing everybody's ears off. There. 27? 27. Now, I think we've done it. Let me check this time. Does the tone appear anywhere else? A little sensitivity check here on the radio. I'll just turn this down. Still hear it there a bit. That's much more normal for this kind of using a transmitting loop. Okay, great. Now we'll try to peak it up. We'll peak it up with this guy up here. You can watch the scope or the meter. The meter is actually a little better to watch. How can you watch the meter? Can you watch that meter? My hand's right in front of it. There we go. Not much here. Let me go a long ways just to make sure there isn't another peak, but no, there isn't. Very clearly right in there. That be it. Okay, AM, all done. What can you pick up? What can you pick up? Lots of noises. Okay, we should start getting stuff. Okay, that's not so good. A couple possibilities here are camera interference, although I've never really experienced camera interference, but I've got a camera stuck right here. Antenna not arranged right is probably the antenna's not directed right. It's pretty close though. Let me put this over this way. Can't imagine that's going to make a difference. That's a bad sign. Let's try the we'll that's very disappointing. I wasn't expecting that. What we'll do is we got the radio tuned down around 600. We'll fire a 600 signal at it. Yeah, there we are. So we're at 550 right now. And we want to take it to 640, where there's actually 590 is a better station. So this is 590. Tune it in. There it is. There should be a station right here. Get the signal generator out of the way. Okay, I can hear it. I'll just try the antenna angle problem here. Oh, I got so much stuff hooked up. I just lost it entirely. Very weak. Okay, one possibility is I replaced the first tube with the original tube. I took out a better tube I thought might be better. Let's find out now. I'll turn the set off. I'll pull this tube out. So this tube is testing slightly in the good range. Let's put it that way. It's testing maybe at I don't know, 60% of what it could be, or 70% of what it could be. Let me just swing this up like that. I have another tube that's testing more like 100% of what it should be. We'll put that in, and we'll see if this makes a difference. It is the front end tube. And I just changed that this morning. I've had this better tube in it for quite a while, but I wanted to put the original back in. Okay, what happens? Just by changing tubes. So this is a 6SA7 RF amplifier and mixer tube. Okay. Now, just throw off the alignment. I don't know. First of all, it's not nearly as loud. Wouldn't you say? Did I turn it down? Yeah, it's turned right down. So that's a little better. Not by much though. Let me tune the radio. Okay, and then I'm going to rotate the antenna a little bit. You know, there's just so much noise in my shop here, I think. So I'm really tipping the antenna to get rid of the noise. Okay, how about some other guys? 590, 610. Nope. 640. Well, that's the best I can do right now. Everything is the way it's supposed to be. It certainly isn't producing the best signal. Was that aimed up at the ceiling, eh? Okay, where are we on the clock here? This is really taking, as usual, a lot longer than I expected. Where are we on the clock? Almost 11 o'clock this morning. Oh boy. Well, I think we should just carry on and we'll do the, we should just do the whole thing at this point, because I don't know what else I can do to peak up this radio on AM. Do the whole thing, get it in the cabinet, and sweat over it at that point. Because I had the feeling if I take this radio out of the shop and put it somewhere else, it's actually going to work really quite well. Okay, so to do the short wave, let me get things set up here for that. Now, just before I give up on the AM here, I really should twiddle the front end tuning capacitor a little bit. Now, I gotta make sure I got the station here. Yeah, I killed those lights earlier. Any station. Shit. There he is. Okay, now we're ready. This is the screw that was way out. Okay, so that screw is supposed to be adjusted at 1400, and I left it backed way out. If you remember that, that's actually the first indication of a problem, is the fact that that trimmer, I could back it all the way out and it looked like it still wanted to go further to reach. There was never a peak. Open coil was the cause of that. Let's go to 1400 here. Okay, 1400 and 1400 down here. Where are you? There it is. Okay, is that 27? 27. Gotta make sure this is right on the money here. I think the meter's a better option. Just right there. Okay, perfectly tuned. Now I'll try that antenna capacitor. Okay, I'm ready. Watching the meter. That's closing it in. That's opening it up. Oh my gosh, not doing anything. Is it? You know what? This is the wrong screw, Jim. For God's sakes, man. This is for shortwave. But that's fine. I haven't got there yet. Just discovered I'd left it open. Okay. No, you know, it's because when I went for my break, I watched news on TV, and it did not relax my brain. Let's try this one. So I should have, I made the mistake. Yeah. So at 1400, this is it. But now, yeah, see, I've been in here too long this morning already. I need a really good break. So we'll go back to the 590. There's something there. Fortunately, there's noise right on top of it. Okay, here we go. That's it. What was that? Oh! My pet cat Peanut has come in. Why aren't you outside? You should be outside. Go outside. Well, he went outside. He's letting me know he's here. I'm indoors, Yeah, I'm gonna have to stop for a while because I'm losing my concentration here totally. Good though. I think AM is where it is. That's my final statement on this. Shortwave is next. Wow, that was a major slugfest.